Hey guys, welcome to my school service calculation. This is going to be the optional method, and I'll be going off of the 2023 NEC. Now this is my crash course series, so I'm going to go through this fairly quickly. I am going to go through each step along the way and give you all the code references, but it's not a complete in-depth commercial calculation like I do in my deep dive series. So if you want to see a deep dive, please check out my video on commercial calculation. I go into a lot more detail on the individual steps there. Okay, before we get into the actual calculation, I've got to talk to you a little bit at first about a change that happened in 2023 that affects this calculation, this optional method for school. As you can see here, there are parts 2, 3, and 4 in Article 220 that we are dealing with. And you can see some of the changes that they made were just in the code sections themselves, and they've rearranged some numbers and shifted some stuff around, and that has affected this calculation. So here we see in part 2, it goes from 220.10 to 220.18, whereas in 2023, it goes from 220.10 to 220.16. And then part 3 goes from 220.40 to 220.61, whereas this is 220.40 to 220.70. And then part 4, 220.80 to 220.103. And in 2023, we have 220.80 to 220.120. So there's some new sections added, and also some have shifted around. The ones that pertain to us, though, are 220.10 and 220.12. And basically these two together are where we calculate our minimum lighting load. And these two sections here have been moved from part 2 to part 3 in the 2023 code. Now it doesn't make that big of a difference until you get to an optional method for a school or a new restaurant. Now what these sections do is basically they are used to calculate your minimum lighting load. And that's when you take the square footage of a building and you multiply by a multiplier found in table 220.42a, and you come up with your minimum lighting load. And in 2020 and before, that's exactly how we did these calculations. However, if you look at 220.86, which is schools, the optional method, it says the calculation of a feeder or service load for school shall be permitted in accordance with table 220.86 in lieu of part 3 of this article, where equipped with electric, space heating, air conditioning, etc., etc. So this part right here, in lieu of part 3, so what it's telling us is we don't take part 3, which is a standard method for demand factors, when we're doing this optional calc. This is found in part 4, and so we leave out part 3 and we're just using part 2. We're basically using all the loads from part 2 and then applying a demand factor in part 4. Now with this shift in 2023, they moved these two, they moved the minimum lighting load to part 3. So what that does is, since we are not using part 3 for this calculation, all of a sudden we don't have a minimum lighting load to use in our calc because part 3 has been exempted. So now we got to figure out how to figure out our lighting loads. And the only way to do that is to actually add up every connected lighting load and add it to the rest of the loads in part 2. Now that is far different from anything we've done in the past, and I'm not sure that the code making panel, when they move these sections to part 3, that they anticipated how it would affect the optional method for a school service or also a new restaurant service. And the reason I wonder that is because they didn't make any kind of notation, no explanatory note or anything telling us that's what their intention was. And it wouldn't be the first time where a new version came out and they had made some changes and they didn't realize the ripple effects that it would have, the unintended consequences that it would have on other sections. And then they had to go in the next round, they had to make some more changes to make up for that mistake. And they may have to do that again here. I'm just not sure what their intent was, but my gut tells me that they did not intend this consequence. Therefore, in this video, I'm going to stick with the original way that we've always done it. And we are going to use the minimum lighting load in our calculation. But I wanted to let you know ahead of time, that's the route we're taking. You know, in case it comes back that they did intend this and they just forgot to mention it, they forgot to make any kind of note regarding it in the code book. And then at the end of this video, I will explain what this would look like if we didn't use the minimum lighting load, if we did take it at face value in the 2023. Now, just a quick note, the rest of this video I made ahead of time. Before I stumbled across this and realized what was going on here, I had already made this video for the optional method, so forgive me if there's a little bit of repetition in the next slide or so. Okay, so for the optional method school calculation, we go to 220.86. But before we get into this, I want to explain a little bit about how Article 220 is laid out, and that'll help us understand what we're doing here and why we're approaching it the way we are. So part 2 of Article 220 tells us about the branch circuit load calculations. It tells us how we establish each load and how we calculate them. And what we would do is we would just add up each branch circuit load and come up with a total, and that would be what we use for our feeder total. However, we are also given part 3, which is a standard feeder and service load calc that gives us some demand factors that we can apply, because they know that not all our loads are going to be used simultaneously. And if we were to add up all of our loads straight up, we'd come up with some huge services that would be way overkill. So they allow us some demand factors we can apply, and we find a lot of those in part 3, which we call the standard method. Also, they give us a part 4, which is an optional method. So it's another method which has different demand factors because it has a different approach to the calculation in general. And it's usually a much quicker calculation to do. It's easier, and typically you'll end up with a lower overall total amperage when you do the optional method. So I'm going to try to make this a little bit clearer. There are 2 different types of loads that are considered in Article 220. You got your connected load and you have your calculated load. Now your connected load is this part 2, the branch circuit load calculations. That is the actual connected circuits to the service. But then when you have your demand factors and you calculate your demand factors, they call that the calculated load. And you can do that using either part 3 or part 4, either the standard or the optional method. So you have your connected load, which is your branch circuits, and then your calculated load, which are your feeder demand factors applied to that connected load. So in this video though, since we're going over the optional method, we will only be dealing with part 2, the branch circuit loads, and then part 4, the optional feeder demand factors we can apply. Okay, so let's go ahead and read through 220.86, schools. It says the calculation of a feeder or service load for schools shall be permitted in accordance with table 220.86 in lieu of part 3 of this article where equipped with electric space heating, air conditioning, or both. Okay, now that's important right there because it's telling us that we're only allowed to use the optional method for schools where it is equipped with electric space heating, air conditioning, or both. So if you don't have that, if you don't have electric heating or air conditioning, then you cannot use the optional method and you have to use part 3 instead. So that's something you got to remember, and that's important. Okay, moving on. It says the connected load to which the demand factors of table 220.86 apply shall include all of the interior and exterior lighting, power, water heating, cooking, other loads, and the larger of the air conditioning load or space heating load within the building or structure. All right, so what we're doing is we're taking all of our branch circuit loads, which is what they're talking about here, all these interior, exterior loads. See, all that, it pretty much includes everything in the building. And then the larger of the air conditioning load or space heating load. So that's the only one where we have to compare the two and find out which one's bigger and only add the bigger one. Okay, so that is, in a nutshell, what we're doing through this calculation. Now this next section here says the feeders and service conductors whose calculated load is determined by this optional calculation shall be permitted to have the neutral load determined by 220.61. We're not dealing with neutral loads in this video. We can find that in another video. And it says where the building or structure load is calculated by this optional method, feeders within the building or structure shall have ampacity as permitted in part 3 of this article. However, the ampacity of an individual feeder shall not be required to be larger than the ampacity for the entire building. That doesn't matter to us here in this video because we're just dealing with the feeder service calculation, not the internal feeders of the building. But just so you know what this is talking about, is let's say you have a sub panel in the building, a feeder for it, and it's a big one. Maybe it's like the kitchen sub panel and you got some really big loads on there and it's a big panel. And I know this is a stretch, but let's say that panel using part 3, you know, the standard method, if you end up with a higher ampacity than the actual service on the building using the optional method, you don't have to use the higher of the two ampacities. That feeder is only required to be as large as your optional method building service ampacity. So that's all that's talking about, not a big deal. The last thing, it says this section shall not apply to portable classroom buildings. So you can't apply the optional method to portables. This is only for a permanent structure. Okay, now here's a table I've developed, and it makes it really nice and easy. You get everything in one shot, the whole calculation. You can see all of your info, all of the data, all the specs of the building as you go along. So you can make sure you didn't forget anything or overlook something. I'll just go through this really quick and then we'll work through an example. We're going to start with the square footage of the building, and we're going to find out a multiplier for that using table 220.42a. We're going to come up with our minimum lighting load. Then we're going to go into all the other loads, and we're just going to list them. We're going to take the nameplate rating of all the loads, including the kitchen equipment, everything at 100%. Then we're going to get down to heating and cooling. We're going to figure out what those are, and then we're going to compare the two and take the larger of the two only. And then we're going to add everything together, get a subtotal. Slide that up here. We're going to continue with the other loads. Now these are the other loads that have special requirements, and that's why I have them separated out. Fixed multi-outlet assemblies, like plug mold. We got just the reciprocal loads, and then any other outlets that weren't included before. Then at the very end, we're going to go back to C, which is our motor loads, and we're going to find the largest motor in the whole building. And I put this here because it's easier once you have all your loads established, then you can look through them and find out what your largest motor is. We're going to take an extra 25% of that and add that to our calculation. So we'll add all these together, we'll come up with a branch circuit total. This is our connected load. Now it told us before that we can apply this to table 220.86, and this is where we get our demand. So this section here is for our school demand. And what we're going to do is we're going to take the connected load and we're going to divide the load by the square footage. And you'll see that when we get to this part in the video, you'll see how this works and why we do it this way. But we basically take the square footage, find out what the VA per square foot is, and then apply the appropriate percentages to that. We'll come up with a total, and that is our building VA. Once we have that, we're going to divide by our voltage, and whether it is single phase or three phase. With a school, it's usually going to be three phase. And so we'll have to multiply the voltage by the square root of 3 first. And then we'll divide it into our VA and we'll come up with our total service amps. Once we do that, we can size our service equipment, our conductors, our conduit, and so forth. Okay, so here is our example. We have a school, it's 82,000 square feet. We have some parking lot lighting, specialty lighting. It tells us our reciprocal loads. We have some water heaters, trash compactor, heating, air conditioning, soda machines, hand dryers. We have some basketball hoop lifts. We have all the kitchen equipment. And we do have a service that's 120, 208 volt, three phase. So we're going to find the total calculated service load. So the first thing we do is we take the square footage of the building and we find a multiplier from table 220.42a. And again, if you want to know why I'm going to table 220.42a, that is explained in my general commercial deep dive video. Please reference that. Check that video out. It has every detail for a commercial service. So we're going to go to this table. Over here on the left is our occupancy types. We're going to follow this down until we find school down here, and that tells us that we have a multiplier of 1.5. So we're going to take 82,000 times 1.5. That gives us a minimum lighting load of 123,000 VA. Okay, now here's something interesting. There was a change done between 2020 and 2023. When the 2023 code came out, they did change this whole table considerably, and they changed some of the values. In fact, in 2020, the multiplier for a school was 3 VA per square foot. Now, in 2023, that multiplier has been cut in half, 1.5. So that's important to think about and to know. So depending on what year, what code cycle your permit was pulled under, that's what you would go with. If it was pulled before the 2023 code was enacted in your area, then you go with 3 VA per square foot. There's a lot of jurisdictions out there that still are under the 2020 or even the 2017 or 20. I think there's still a few areas that still have the 2008 code. So anyway, just check to make sure what code cycle you are under. Okay, and moving on, we're going to our other loads, and this is going to be the lion's share of the rest of the calculation. Most all the other loads are going to be in this section. Okay, we're going to start up here. We have some parking lot lighting and some specialty lighting. I just put those two together under specific lighting, and then I multiply by 125% because they are continuous loads. Remember that any commercial lighting generally is considered a continuous load. So we add an extra 25% to that, and we come up with 9,200. Then we add our water heaters. We have 7 of them at 5,500 watts. Right here, 38,500. Then we have our compactor, soda machines, hand dryers, hoop lifts. And then we have all the kitchen equipment here. I grouped it all together at 73,400. Okay, next we have our heating and cooling, which I've shaded in green here because it's the only one where we don't just take the nameplate rating and add it in. We have to compare the two, heating and cooling. We have 6 30 kW heating units and 6 15 kW air conditioners. That comes out to 180,000 for the heating and 90,000 for the cooling. Comparing the two, we take the heating, of course, it's the larger, 180,000. We're just going to add all these bold numbers up together. We get a subtotal of 446,580 VA. And that does it for the first column. We're going to slide that subtotal right up here, 446,580. Then we're going to continue with our other loads. We don't have any plug mold or anything, so we have 0 there. Our reciprocal outlets, they tell us we have 45,360, so I put that there. We don't have any other outlets. Now it's time for our largest motor. We're going to go through our whole calculation and find out what our largest motor is, and that's going to end up being one of our cooling units. So one of these air conditioners, 15 kW, 25% of that is 3750, so we're going to put 3750 right here. We're going to add up all these numbers and we come up with a branch circuit total of 495,690 VA, and that is our connected load. Now, real quick side note, if you're wondering why I added the largest motor here like I did, please check out my non-coincident load video. It includes the largest motor in it because it's very connected. So check out that video if you have any questions on that. Okay, so now that we have our connected load, if you remember, back here at 220.86, it told us that the calculation of the feeder or service load for school shall be permitted in accordance with table 220.86 in lieu of part 3 of this article. So since we have electric space heating and air conditioning, actually we have both of them, we can apply table 220.86 and use the optional method. So that's what we're going to do now. And it is the connected load to which the demand factors of table 220.86 are applied. So let's go ahead and take a look at table 220.86. So it says optional method, demand factors for feeders and service conductors for schools. Okay, so you have your connected load over here. And we're not dealing with meters, we're dealing with feet, so we'll stay with this column here. And it says total VA per square foot. And you have the first 3, 0 to 3. Then you have the next 3 on up to 20, from 3 to 20. And then anything over 20, the remainder, you have that category. And so for each of these categories, you have a different percent demand factor that you will apply. So for the first 3, we'll apply 100%, the full value. And that will be our calculated load. For anything 3 to 20, so the next 17 VA per square foot, we apply a 75% demand factor. And then we add 3. And the remainder over 20, we add a 25% demand factor and then add 15.75. So how that works is we're going to use the little table over here. We have our connected load, 495,690 from right here, connected load. We're going to divide by the building square foot, which is 82,000. And we come up with our total VA per square foot, which is 6.045. So that is our VA per square foot for the building off of our connected load. Now we go to table 220.86, and it says to take the first 3 VA per square foot at 100%. So we're going to take the first 3 at 100%, and that is 3. Then we take the next 17 VA per square foot at 75%. So 6.045 minus 3 is 3.045. Multiply that by 75%, we get 2.28375 VA per square foot. And of course, we didn't have anything beyond that, so we don't have to worry about this last category here with the remainder. Then we just add the 3 to the 2.28375, and we get 5.23875, and that is our VA per square foot with our demand calculated. Once we have that, all we have to do is multiply by our square footage of the building, 82,000, and we get a total building VA, 433,268. So just to recap real quickly, we took our 3 at 100%, that's the first line. Then we took everything left over at 75%, that's the second line. And then it tells us we have to add those 3 back in there. And that's what we did. We added the 3 back into the 2.28375. That gave us this number. And then we multiply by our square footage, and we get 433,268 for our calculated total building VA. So that is what we have right here. Our total building VA is 433,268. Now, if you're wondering why these numbers here are a little different, is because there's 2 ways you can do this, and I told you the first way, which I think is the best way, and then this way, you can also do it this way. It's maybe not quite as simple, but you just take each one and multiply it out individually, and then you add them together. Come up with the same result. Okay, once you have the VA, we're going to divide by our voltage, but it's 3-phase. So first we got to multiply our voltage, 208 times 1.732, and then we're going to divide 433,268 by that number, and we come up with 1,452 amps for our service amperage. Okay, and here's the whole problem, so you can see everything filled in. You've got all your loads over here, and then we apply our demand from part 4, the optional method, and we come up with our building total. Okay, now we're going to go back to what we talked about at the beginning of this video about the change they made from 2020 to 2023 and what that would mean for this calculation. So remember, we were talking about the minimum lighting load here. This first section, these first 3 rows here, are dealing with the minimum lighting load. And in the 2023, that shifts to part number 3 of 220, and therefore is exempt from this calculation. So if we were to take this at face value, this part would no longer be calculated as a minimum lighting load, and we would just take a total of all connected lighting loads in the building. Again, my gut tells me that this is not what they intended, but that's what it would look like. We'd total up every single lighting fixture, exterior, interior, everything on the service, and then we would add that total to the rest of these loads here, come up with a subtotal, and then we just continue to do the rest of the calculation just like we did earlier. And then it's almost guaranteed that this final number is going to be quite a bit bigger doing it that way, because you're not able to apply that minimum lighting load demand factor. Anyway, we will see how this turns out. Maybe in 2026 they will make another note or a change to make this clearer so everybody knows what their intent actually was. But until then, I'm going to go with my gut, and I'm going to include the minimum lighting load in my calculations. Okay, and here you go. I took the color out of it, so it's easier for you to get a screenshot. Go ahead and make copies, use it as a worksheet, whatever you want to do with it. Hey, thanks a lot, guys, for watching. If you found this helpful, please give me a like. And if you haven't subscribed to my channel, please do that. That'll help me get this out to more people, and it can help them as well. I have a lot of other videos on the channel. Please check them out. And please let me know what else you want to see video on, and I'll see what I can do about that. All right, well, thanks again, and I will see you next time.